Alright, it should be recording. I better check. Haven't used this computer in a little while. Anyway, yeah, I need to draw, so using the drawing table format. So anyway, the Richie guy make a video here that's really anyway, I mean, it's hard to, this whole dissident thing, you know, yes, there's a lot of fringe people, you know, they're just of all kinds of eccentricity. And it's a real liability because, yeah, as a group, it does look like they're all insane. And there's nothing we can do about that. And I don't agree with any of the dissidents. You know, they're all just as wrong as conventional physics, and their physics is just as weakly evidenced, and they don't draw any pictures of anything that could be considered something rational. Now, I like Bill Gates because he actually argues that, yeah, you should be able to draw a picture of it. His drawings are insane. I mean, you know, he can't even draw what he thinks reality is, which is these stupid ropes tying every atom to every atom, which is just, in my opinion, on its face, just too silly. But anyway, yeah. So anyway, so let's play this. I mean, you know, I could understand hostility, you know, and but there's, you know, there's a line, and you know, there's no point in conversation where I have to argue with things that are imagined rather than things that have anything concrete or that there's any evidence of them. You can't make claims that you don't support with some sort of evidence or a drawing or something. You can't just say there's a tornado on the top of a magnet. I mean, it's sort of a bold claim, and if it exists, you should be able to show evidence of it. And again, if your evidence is electrolysis in you know, in water, again, the explanation of the effect is completely different than what you're claiming it to be caused by.
G'day, viewers.
So anyway, we'll get to the two-slit experiment here. And so I will point out some features that no one's responded to in any kind of coherent way.
Back into the old electrical theory now.
So he thinks there's something, physics is one subject and electricity is some other kind of subject, which is just kind of crazy. Electrical is physics. It can't be called anything else.
And the first assignment, believe it or not, is the double slit experiment. I can't believe you people haven't solved it in 218 years after Thomas Young did it in 1801.
And again, it's, as I've pointed out, it really hasn't been explained since Newton did it in 1650 whatever. It hasn't been explained since then. So you know, we never explained Newton's rings. And then Newton did the single hair thing, which is essentially the, you know, slit experiment in reciprocal form.
And what are you doing? Sitting on your hands.
So again, you have the answer, so why don't you provide it?
I solved it after thinking about it and hearing everyone rave on about this double slit experiment. I thought, surely it can't be that hard. And
so we're getting the backstory. We're not going to get the story. We're just going to get the backstory. Yeah.
Tried a few different angles. I tried different people's suggestions about material interface layers. And I thought, yeah, well, no.
I guess you should have drawn some of that, or I don't know how you tried it. You mean you tried it on paper or something? You simulated the experiment in your imagination?
Didn't work. Then I hear some people say, oh, energy travels in waves.
Yeah, so I don't know who, again, if you're going to cite something, you ought to just say who. You know, I heard some people. Or where'd you hear those people?
And other people are saying, oh, photons have got mass. No, they don't.
Nah, not. So you're making an assertion. All right, what we know they have is momentum. Clearly, they do impact things. They burn skin. They do all kinds of stuff that is just overt evidence that they have momentum. So the idea that something moving, we know they move. And so if they were massless, how would they convey the momentum? If they don't have mass, how do they convey momentum? And that's kind of a silly concept, isn't it? Yeah, I think it's silly. But I personally think it's silly.
Don't have mass, and it's been proven otherwise.
Oh, so again, it's been proven by what? Okay, so he's going to say otherwise here, like this is going to, like it's going to somehow show me the proof. So this is going to be his proof.
As your light bulbs would evaporate and float away.
Why? I mean, you know, the energy in clearly has momentum too. The electricity, we can watch electricity burn holes in things. Clearly, those things have the capacity to impose a consequence of momentum. So the force that you're putting into the light bulb is already got mass and momentum. That's why it's capable of creating particles that have mass and momentum. So why would my light bulb float away? I'm putting energy, theoretically trying to go the speed of light, going very close to it, pressure, voltage, into the wire, and I'm getting out pretty much the same crap, moving the same speed, except now it has a frequency, and I can detect it with my eyeball, or I can detect it with a device that can measure the infrared heat, or I can see the other photons. But it's the same energy. It's just when it comes out, it's at a frequency because it's vibrated electrons. Why would the light bulb evaporate? It's not burning its mass, and clearly the momentum of the electricity does degrade the filament. It does break it eventually. The heat it's creating.
What an idiot statement.
Okay, idiot statement. Why?
We're looking at the field geometry of photons.
Okay, so field geometry, what does that mean? The field geometry of photons, just mushy words. What does that mean? The consistency of the photonic jello. Oh, that. Yeah, no, I don't believe in photonic jello.
Wave propagation.
Well, again, so you don't believe it's a wave, and then you say something like wave propagation. And I'm supposed to say, oh yeah, this guy's rational, he's grounded, he knows what words mean, he's got it under control. No. So now it's jiggling jello.
100% predictable pattern.
100% predictable pattern. Well, that's the only thing everybody agrees on. But what does that have to do with anything? Yeah, it's a predictable outcome. The photon won't go to Venus, okay? In spite of what Richard Feynman says, none of them are going to get there, okay? It's just not going to happen. And so, yeah, we kind of know that it's predictable that it'll be a certain number of them are going to go in certain locations. Yeah. Yep, we all agree on that.
And why it happened.
Why? Why? That's the question. Why? Why did the photons go there? Yes, that's what we're after. The explanation for why.
Happens. And it's beautiful. When it comes together, you see the inner beauty of the universe.
So that just sounds like religion to me, so sorry. Total fail. What does beauty have to do with any of this stuff? It's just a silly word. It's like garbage science. You know, what, the love index, the pretty times squared or something. It's pretty cubed. No, I don't think so.
And it's an electric solution.
Yes, and electricity is what? Oh, a force moving just about the speed of light. So, let's see, maybe it could be made of the same exact stuff as I've said before. All the forces moving the same speed are the same stuff, just merely at a frequency or segregated for their two forms. So, you can have the force just randomly placed, or you can have the force where it's at a consistent frequency, distance from each other. Or you can have the force, all the plus force goes this way and all the negative force goes that way. So you can segregate it. Those are the three forms. Done. You know, finished.
It's nothing. Some people go, it's physics. It's not physics.
Well, another statement, okay. I just don't think you could, with the nature, how we've put words together, I think it would be kind of impossible to extract electricity from the subject of physics. I think that would be quantum electrodynamics. It should be what, quantum nothing dynamics?
It's simple electrical theory.
And there's such a thing as a simple electrical theory. Somebody has one of those. No, I don't think so. They have virtual photons. Is that simple? Again, you're going to draw me a picture of why magnets attract, please? Yeah, go ahead. Draw me a picture of it. Show me.
I'm not going to release it just yet.
For what crazy or useless reason?
You can all wait. You can wait till the 22nd of February.
International Pea Brain Day.
I should make you wait till the 22nd of February 2020.
The year of the, I don't know, rat poo?
But I'll be nice and I'll be generous. Unlike some of you half-wits out there. Abusing everybody, calling us all.
So he calls somebody a half-wit and then complains about people calling other people half-wits. Hilarious.
Oh, idiots. You know how.
Or they call what you're saying idiotic. That's probably the more likely. They're saying what you're saying is idiotic. That's idiotic. Because it is idiotic.
I'm talking about. I'll give you the solution to the double slit experiment. And you'll kick yourself because it's that simple.
I bet you not. Okay, I bet I won't kick myself, but I might hurt myself, you know, chuckling and such.
I cannot believe you talking monkeys haven't figured it out.
So again, it's fine. I mean, if you're going to set a standard, like you say, oh, they're using bad language and calling people booger heads. But then you can't do it, you see, because that's just saying two wrongs make a right or something. You're supposed to show how you do it without calling somebody a dirty little name. And you just showed that you resort to the same tactic, so you sort of fail. Yeah, you fail.
And I'm the same guy that sorted the 37-year problem out in 24 hours.
So he's the same guy that sorted it out in 24 hours. The 37-year problem? What 37-year problem was that? I don't know.
So don't give me your bullshit.
You're the one, I think, you know, with the big bag of bullshit, you know, shoveling it out. Sorry.
Tell me how smart you are.
I don't think that's the point. The point is really, how crazy are you? Yeah, that's the one. Yeah, that's the question.
You're retards. Yes, I said retards. It's the same word that you called me a dumbass.
Or a pea brain, yes.
Who's the dumbass now?
I believe you still are.
Under a week to sort this problem out. Under a week.
Yeah, it's all talk, isn't it? So you really think this is the right way to do something, is do all this hype like you got some great solution. No, I don't think so.
Bloody disgusted in this.
Yes.
Not interested in physics. I mean.
Yes, you're interested in just talking, apparently, and not demonstrating. So, yes, all talk, no demonstrate. Great.
Interested in electrical theory.
Well, that's physics.
Because that's where I rule.
I doubt it. Yeah, no, I don't think so.
You'll be seeing a bit later. If you don't want to watch me videos in between, come back on the 22nd of February and I'll show all about it.
Yes, because it's the special day. You know, that's what the numerologist told you what day to use. Yes, that's your lucky day.
And then you learn.
Yes, right.
Can we,
I'll learn that, goddamn, this is impossible. Human beings are they're either dumb as sticks or crazy as sticks.
Wheeler, DraftScience, these are all wrong, and yet these are all right.
Well, that made no sense. Obviously, Ken Wheeler is a charlatan, a fraud, a fake, a coward. Can't defend any of his horseshit with a single shred of real evidence for anything he says. Coaxial cable? Who could that make sense to? Lights like a coaxial cable. Makes no sense at all. Jello would make more sense. Coaxial cable? No sense.
A little bit of each, but you've got to get it all right. Not half right, half wrong. You've got to get it 100% right.
Yes, and you'll demonstrate nothing. Again, so demonstrate one thing I'm wrong about. Go ahead. Make some kind of rational argument pointing out how, okay, DraftScience says this, and this is how I can prove that's wrong. Why don't you do that on one single subject?
So you can stick that in your pipe and smoke it.
You didn't put anything in any pipes. There's nothing to smoke, okay? You got nothing, okay? You got words. That's it. All right, so off to the drawing, I suppose. All right, so as I've brought up in a couple of videos, and I think I just pointed out and illustrated if possible, because apparently people need that, maybe. All right, so the last demonstration I did from the Royal Institute guy, you could see that his pattern was full of circles. Okay, so it was a big blob of circles, and then there was another section of circles, and another section of circles. And so clearly it was a double slit pattern in that it had the thing that makes double slit patterns a thing, which is these groupings. Okay, there's groups of pattern, big group in the middle, and then a bunch of little groups on the sides, where the single pattern at the same width opening will just create the pattern. Okay, and the middle ones will be bright, and as they go further away they get dimmer. So this middle ones will be very bright, and they'll get dimmer as they go over here. And the two slit, the consistency of the brightness, the middle isn't nearly as bright, which sort of makes sense because there's an impediment in the middle. So you don't have any light going straight through. But this is basically the difference between the patterns. So there's two parts, there's two aspects that make the single and double slit different. One of them is this single part here in the middle, also in the single slit, is actually made out of three things. The middle one is actually off. There's actually an off in here, but you don't see the off because the light goes straight into it. So you don't see the off. So this looks like one big on in the middle, and then you have the rest of the pattern. And the double slit, like I said, it's not quite as bright, so you don't have because you're blocking the light with the impediment. You don't have the problem of the light going straight through the slit, so you don't have as harsh a brightness here. But you could see in the experiment as done, this section was much brighter than these other sections. All right, so in the one we saw, they were actually circles like this. Okay, they were a bunch of circles, 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 instead of what we traditionally see, which are bars. And when the slit, the experiment is done in other mechanisms. Now, I've said simply, why doesn't somebody want to explain that to me? Why in one experiment are they circles, and why in the other experiment are they rectangles? And I would argue because it just has to do with the size of the beam. So when the beam is going into the experiment, let's just make this impediment here. If the beam is much bigger than the slits, you'll get the rectangles, because this part of the light's never going to get into the slits. And when the beam is much, the same size as the opening, that is the slit width and the impediment and the other slit, if the beam is just the same size or a little bit smaller, then you'll end up with an image of the beam being broadcast to the different locations. So you actually see the shape of the beam. And that's why there's circles, and that's why there's rectangles. So that explains that function. Now, you also, another way to corroborate that theory is to understand that the diffraction gradient, which is really just numerous slits, okay, basically takes the image of the laser, and it also ends up round because the laser beam is usually round. Now, you can buy toy lasers, so to speak, laser pointers, and what they basically do is they have a little, they'll have a star cut out on the laser beam, okay, and then they send it through a diffraction gradient, okay, covered over the top of the laser. So the laser's like this, the beam comes through, the beam hits the star shape, and then the star shape goes into this diffraction gradient, and it's diffracted in both directions, and it makes a pattern of stars, okay, in these locations. So it makes stars. You can make a whole bunch of stars spread out on the wall. So it's a nice little toy because it makes a little star pattern. So clearly the pattern of the light hits the diffraction gradient, and each one of these little slits, each one of the grading elements is quite obviously sending what it gets as light to each one of these locations. So each location is sending a photon to all those locations. And yes, it's probabilistic. And as it turns out, because it's a diffraction gradient, the probability ends up being quite even. So all of them end up being 10% or whatever of the light, whatever the number would be. So they all end up being somewhat equally bright. The ones in the middle are going to be brighter than the ones on the outside for obvious reasons. So here you have your first indication, one indication, that all that really happens in the slit experiment, like say all this is more slits, right? Okay, it's not like magic. I mean, of course it's a lot more slits. It could be like 1,000 of them per inch, but they're just more slits. And that's all the difference is, really. It's just more. So if I make less and less slits, what will happen is these stars will start getting closer and closer together. They won't be as diverged, okay? And the argument could be made that, oh, okay, once I start making them closer and closer together, I'm just going to end up with a double slit pattern. I'm just going to end up with a pattern, okay, as I just get rid of more and more bars. And so theoretically, I'm arguing that what you're seeing when you see this bar pattern is you're just seeing the slit pattern duplicated, the walls. Okay, you're shining light through two openings, and if your beam of light is much bigger than the openings, then what you're going to end up with is a duplicate of the openings. And it's just going to send a duplicate of the openings, the walls, to each location. So by probabilistic laws, more in the center, less out here, photons will go to those locations, and they reproduce every aspect of the wall. So a photon hits here, a photon hits here, a photon hits here, a photon hits here, hits here, hits here, and they all go to all these locations by a probabilistic law, rule, because of a real thing that causes a real angular change. Now, if this was wave interference, it wouldn't account for any of this, because we're supposed to get a gradual gradations and gradations back up. And the whole reason why we don't have that nice, the pattern is supposed to be light, and then it gradually gets dark, and then it gradually gets light again, and it gradually gets dark. The reason why you don't have that is because there's images. There's no reason for the images to be gradually lighter and darker. They're broadcasting an image. So it's another reason to say, oh yeah, this explanation makes more sense because it actually fits the pattern you see rather than the pattern they mathematically think they're seeing. The mathematical pattern isn't what you get. Now with electrons, it does work because, well, electrons hitting electrons, as I pointed out, is different because electrons never really hit each other. They bounce off each other's radiation. So they're blendy because they can bounce off at all kinds of angles. They don't have to bounce off at a very precise angle. Within limits. So they spread more as they're bouncing. So that's why everything's softer. But the same thing is really happening. It's a momentum exchange. All right, so so these are just facts. That's all, right? There's nothing I'm saying here that's impossible or not reasonable. If you have some other explanation for how the diffraction gradient works, that it does actually transfer images of the beam, do you have any counter argument that demonstrates that's not what happens? Does anybody have any counter evidence to that they can suggest, that they're willing to say here's counter evidence that proves it's actually a wave? Because it's clear to me that these are just images ending up in these different locations because of some phenomenon inside the slit. So what do we know happens inside of these two slits, right? So the idea is when I make the slits closer and closer, as I move them closer together, you can sort of understand that whatever lumpiness is in their surface, that lumpiness is going to be more and more capable of affecting each photon. So the closer they get to each other, these two walls, the more likely that any photon going through is going to end up hitting some of this lumpiness. And you could argue that the lumpiness could get thicker at the surfaces as it goes, the lumpiness is less in the middle and it gets thicker and thicker as you get near the surfaces. You could argue that's probably sensible. And so you have a real field here. And this is kind of an experiment that I sort of have demonstrated, that you can do this silly thing where you just put your fingers together, all right, on a lit surface, and you'll see little lines form. So if you do it in front of your computer screen, you'll see little lines form. I mean, the closer you get to your eye, the better it works. So I'm trying to get, I'm just not light enough here, I think. But you can see the little lines will start to form, little black lines. So, indicating that there really might be some kind of field being created, and the field would be made of something like electrons, and that they might be lining up, in some sort of arrangement, as is a consequence of the fact that I've brought two surfaces that have charge close to each other. So I have a field of different density, and one could argue that the photon that goes right through here ends up getting reflected by, 70 degrees, because it hits lots of stuff, and the one that goes through here only gets deflected by 10 degrees. And that's basically all that's happening. And these are all multiples, by the way, so each time you hit something you could argue that you're deflected by 3 degrees, and it's 3 degrees, 6 degrees, 9 degrees, 12, 15. So that's the mathematics demonstrates that that's what they predict. It's very consistent. Okay, the pattern's not random in any way. It's very consistent. It's just the same thing multiplied by the n number. That is the number of spaces from one you are. So it's position 2, 3, 4, 5. It's just a multiple of the angle. So the math is pretty simple. The geometry is pretty simple. And clearly it can be easily explained as just a physical phenomenon. As I make the two surfaces closer and closer, I change the atmosphere in between those two surfaces, and that the electrons coming off the surface of the whatever it is are intermingling with the air molecules, and there's electrons and energy potentials being established. They're repelling each other, they're getting pushed on, they're contracting, they're pressurizing, they're acquiring a voltage essentially, and yes, when you shine light through it, you're going to get a result. And it sort of explains why, depending on how you do the experiment, your pattern does go all kinds of different wackiness, right? If I do it out of paper, I get one kind of pattern. I do it out of metal, I get another pattern. It's very hard to create two perfectly identical patterns. If you were to try to set up the experiment, even with two perfect slides right next to each other, right above each other, the two patterns won't necessarily be exactly the same. There'll be little subtle differences, more spread in different directions. The thing is very, a little tiny change makes a huge change in the pattern. All right, so the other subject, So I think that's enough, right? I mean, I've given you more than enough to indicate there's a perfectly rational explanation. You don't have to have multiverses created. I don't have to make photons turn into special wave functions. Often they say this wave stuff doesn't even happen. He says the real physicists all believe that it just as it goes through the slit, it's assigned a poofy random number, and it just goes wherever it has a poofy random number to. The poof god gave it a poof number, and it poofs to the right place because it's got the probability poof number assigned to it by the magical random poof number assigner. Yeah, I know that's worse than a God theory, right? I mean, the Muslims have a more rational theory of existence than that mush. So yeah, that's just crap. So another thing I was thinking about, I mean, I keep pointing out how, well, I have lately been pointing out how, this whole eyeball thing has us really confused about how the real world works, because we don't realize how it's filtering out so much of the world we see. There's only certain light from certain angles can get through that little tiny frickin' hole to create what we see as an image of reality, on our retina. So we see a very selected portion of reality. And if you actually get rid of the eyeball and the aperture and just shine light directly on our retina, guess what you're going to get? You're going to get blah, 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 blah. You're not going to get an image of anything, because you are then going to get all this diffracted light. You're going to get all this patterned light. All these weird things are going to get in there. See, if I was to look through a half-silvered mirror, the truth is all the light is getting diffracted, coming through the mirror, hitting all those surfaces. But my eye can only see one ray of any one element of that mirror. It can't see all of the refraction because it's only going to pick up one single piece of it from one single piece of the Newton's ring. It's not going to pick up 3 of the Newton's rings worth. I'd have to be right up next to it, right? I'd have to have my eye right up next to the silver to have any hope of seeing multiple images. Because as soon as I get any distance away, only one of the images, only one of the Newton rings can get in my pupil. So only one from any one location. I can only get one ray of light from one ring. I can't get a ray from this ring and this ring and this ring and this ring. They just spread right past my pupil. So I only get one ray from every location. That's it. I don't get multiple rings worth. So that's a huge reason that we see the world so coherently, is because we can actually filter it, all the noise out. Like I say, if I put just a piece of photographic film, I say, just expose it to the world facing me right here, and I expose it just quickly so I don't, like overexpose it. So like I do it in a dark room, and I try to make an image on this film. I have no hope because there's so much noise. There's so much reflections and garbage and diffractions and refractions. I'm not going to get shit on that piece of photographic film. It's going to look at the world, and it's not going to mirror anything rational. So it's going to be an image of nothing, just blobs. I'm just going to have blobs because the light is so corrupt when it's coming off all these surfaces. And we just don't see how corrupt it is because we only see one of the rings at a time. But it's all sending out a bunch of light with all kinds of diffraction patterns in it. So it's this has been this is the huge deception, right? I didn't figure this out till just a week ago, that this aperture thing is huge. This idea of forcing the light through the hole. That's why the pinhole camera works. If I open the box, no image. If I close the box and have a little pinhole in it, I get an image, because it's filtering out all the noise. And it's huge to understanding what photons are really doing, just how dense they are, how many of them are, and how our eyeball, our pupil, is doing the work, not the lens. The lens is nothing. That fucking hole, that's everything in terms of filtering out all the crap. And, you know, that's really got to be understood, that we're not seeing the world the way it is. We're seeing it filtered. And the filter is essentially undoing what all the little apertures and all the bent surfaces and all the crooked shit, the way it is screwing up so much light. It's getting rid of all that screwed up diffraction, all the noise light going in all these directions and all these angles. It's getting rid of all that crap. So we can see a very precise one photon from each, one ray from each location. And that's what makes us see a coherent world. It's what makes us see. We can't see without it. You can't see without a small aperture. Without a small aperture, you're blind. All right. There's so much noise. There's so much diffraction, diffused, scattered light. There's so much scatter that you couldn't see reality through all the scatter. All right, so it's probably enough of a statement. Counter arguments, welcome, but I haven't heard anything close to one. Please, somebody explain to me why the round holes, you know, things, why the rectangles, why are the rectangles clearly very harsh instead of being blended, and why, when we have proven evidence that the diffraction gradient is actually putting whole images in each location, we know that's what's happening, why are we pretending that those are wave interference? Wave interference doesn't do that. Wave interference isn't going to give you duplicates of the image at each location. So why are you pretending this subject shouldn't be over already? It should be over already. Or explain to me how wave interference creates duplicate images. Go ahead, explain to me how wave interference can create duplicate images in each location. Each little bar of the star. How does this side of the star and this side of the star get to this location, this location, this location, and this location through wave interference? All right, probably enough. It's never enough, but it's just, I'll say it's enough. I'll declare it so. Make it so, as Captain Petard would say. Petard. Yeah, that should have been his name. Captain Petard. Oh, yes. Fucktard. Captain Fucktard. Anyway, ludicrous speed. Where am I supposed to hit? I forget. Control R.